Hello everyone, my name is Sarfraj Kathat. My college ID is 17MA61. I am a BTech final year student. I am pursuing my BTech in Mechanical Engineering from Engineering College Ajmer. Today my seminar topic is Embedded Systems in Automobiles. It is under the guidance of Mr. Mulchan Khatri sir, Assistant Professor in Engineering College Ajmer.
In this PPT, we will learn about embedded systems and their working in applications in automobile and other industries, and about the wide variables in self-driving vehicles and adaptive cruise control (ACC). Let's start with introduction of embedded system. An embedded system is a device controlled by instructions stored on a chip. These devices are usually controlled by a microprocessor that executes the instructions stored on a read-only memory. We read in newspapers that Dr. Ed successfully transplanted a cardiac pacemaker in his patient's chest by sitting around 200 km away. Also, we know about driverless car that could take us to destiny by using its navigation system. Embedded microprocessor are the brain behind using this. The software for the embedded system is called firmware. Embedded systems are also known as real-time systems since they respond to an input or event and produce the result within a guaranteed time period. Let's talk about its application. These are the application of embedded systems. It uses in automobiles, subways, aircraft, railways, traffic controls, process control in many plants, medical systems, military, manufacturing, telecom industry, computer games, multimedia, households, and etc. These are used in various panels. Now we will discuss about embedded system in a car. There are three parts: comfort and convenience, driver assistance system, information and communication. So there are so many parts are used in a car which is used embedded systems. In the driving seat we can see many controls in which embedded system are used in these controls. For example, ABS anti-brake system, fuel injection, airbags, GPS, CD player, window defroster, fuel quality monitoring, automotive transaction system, and etc. There are so many parts. The doctor will see now what it's mean. Embedded technologies advance are pointing towards the use of pacemakers that can be transported in or near the heart itself. The pacemaker will be able to monitor parameters like blood pressure, blood flow, pulse rate, etc. using microsensor planted in various parts of body. Embedded system work like this. Where variables are embedded systems have a small footprints and consume very little power, which makes them ideal for variables computing applications. The minimal system requirements of these devices ensure that the hardware is almost microscopic. You don't need to keep your eyes on the road because embedded system can make driverless car a reality. Major automobiles manufacturers are already engaged in work on these concepts. One such technology is adaptive cruise control (ACC). Let's discuss about ACC. ACC allows car to keep safe distance from other vehicle on busy highway. The driver can set the speed of his car and the distance between his car and other. When traffic slows down, ACC alerts vehicle speed using neutral braking. As we can see in this slide, each car with ACC has a microwave radar unit which determines the distance and the relative speed of the car and the other car. The working principle of adaptive cruise control is each car which ACC have a microwave radar unit fixed in front of it determine the distance and relative speed of any vehicle in its path. The ACC works on Doppler effect. Now discuss what is Doppler effect. Doppler effect is the change in frequency of the waves when there is a relative motion between the transmitting and receiving units. The Doppler effect can be categorized in two ways. First, higher pitch sound. In this case, the vehicle is speeding towards the stationary listener. The distance between listener and the car is decreasing. Then the listener will hear a higher pitch sound from the car, which means the frequency of sound is increased. Second is lower pitch sound. In this case, the vehicle is moving away from the listener. The distance between the car and listener is increasing, then the listener will hear a lower pitch sound from the car, which means the frequency of sound is decreased. So that is the Doppler effect in case of sound waves. Working of ACC. In the above case, the ACC work on, as we know, ACC work on Doppler effect. So we can see that in this slide we can design the chip or ACC having an algorithm such that it will give output only when the input signal are less than the corresponding safe distance value. So only when the between the car and the object in front of it is less than the same distance value, the embedded system will give output to the braking and the accelerating unit. Thus the safe distance will be kept always. That's how the ACC work. We can also see in this slide the ACC makes safe distance between the two cars. Now about the beauty of adaptive cruise control. By all the parameters, ACC makes driverless vehicle or self-drive vehicles at a safe distance behind your car settles to a speed matching that of the driver in front of you. That's too slow. After looking in your rear view mirror, you pull into the empty outside lane and feel the acceleration as your car speeds up the precise cruising speed. You still haven't pressed the accelerator pedal. That's the beauty of that's the beauty of this racing star of the auto industry. A millimeter wave radar technology that promises to make driving easier. Now we come on conclusion that embedded system can be used to implement features ranging from the way pacemakers operate and mobile phone that can be worn as jewelry to adaptive cruise control ACC. Thank you. This is the end of presentation. I hope you are able to learn about embedded system and its role in automobile. Thank you very much for listening. If you have any question, please ask your query in comment section. Thank you.